Fourth in our seminar series. Today we're going to be focusing on crop competition and the impact that it can have on weed populations in cropping systems. So in general, our research has focused on trying to improve the competitive ability of the mostly non-competitive legume crops. So we'll be hearing a bit about that today. As previously, you can post your questions in the chat room as we're going through these presentations, and then we'll have time to address these questions after each presentation. So first up today, we've got Asad. So I'll leave it to you, Asad, to take it away.
Thank you, Michael. I'll just start sharing my screen. All right. You always see and hear me?
Yep, all good, Asad.
All right. Okay. Good afternoon, everyone. Today I'm going to present my talk on some updates from Northern Region crop competition trials, mainly the maximizing crop competition in summer and winter crops. So this talk will be presented jointly by myself and Adam McKiernan from QDAF. So I would be presenting some results from winter crops trials done at Narrabri and Warwick. So I'll present like from season-wise, starting from Faba bins, and Adam will present results of these trials on chickpea and some summer crop competition trials at Warwick. So I'll kick off. So weeds reduce crop yields and increase the crop production costs. And weeds are mainly controlled through herbicides in broadacre Australian farming systems. However, reliance on herbicides has resulted in evolution of resistance in many weeds. So non-chemical control strategies such as crop competition are needed to complement it with herbicides for the sustainability of this precious, herbicide control strategy. So crop competitiveness can be enhanced by selecting more weed suppressive crop or by manipulation of agronomic practices that favor the crop. So as I said that I'm going to present my work on from the field trial conducted at Narrabri on Faba bean. So the main aims of this trial were to measure the impact of Faba bean cultivar, row spacing, and crop density on common sow thistle, biomass, and seed production. So common sow thistle is a pretty problematic weed, and it has already developed resistance against a number of herbicides like group and it is a prolific seed producer weed, and it has a pappus attached to their seeds, and which helps them its spread to new locations. So for this trial, we have following treatments. we used 3 cultivars. At Narrabri, we used Nazma, Warda, and Mung. And at Warwick, Nazma, Warda, and Nanu. So there was one variety difference at both locations, but 3 cultivars were selected. And there were 2 row spacings. Faba bean were planted at 25 or 50 centimeter row spacing. And there were 2 densities of faba bean, so 20 and 30 plants per meter square. And there was a 1 crop-free treatment where there was no crop was planted. And for common sow thistles, we tested 3 densities of that's without sow thistle, with 5 and 10 plants per meter square. And these were like a subplot treatments within the main plot of the crops. As you can see from on the top, on your right, you will see that there's a wider row spacing. Faba bean planted on wider row spacing. In the middle, it's one just planted on narrow row spacing of 50 centimeter, and it's a crop-free treatment on your left. So what we approach, we use the planting dates were like, there was a difference of planting time at Narrabri. The trial was planted on 26th April, and in Warwick, it was on 29th of May, 2019. So at Narrabri, we transplanted the wheat seedlings at the rate of 10 and 20 wheat seedlings in 2 meter square quadrate area. So these quadrates were fixed, as you can see from the photo on your right bottom. Here you can see there are a fixed quadrate. That's where within those quadrate treatments, subplots, we transplanted weeds inside with this ratio at the time of, about 2 weeks after emergence. However, at Warwick, the strategy was a bit different, and crop seed was spread at the time of faba bean planting, and it was irrigated, and it just came up after that. And later, the weed density was thinned down to the required density within each treatment of subplots. So we thin down the crop density within the fixed quadrate areas. Like we have 2 treatments of crop density, 20 and 30 plants, and it was if there was a generally we planted with a slightly higher density, and it was later thinned down to the required density of crop, which is required within each treatment. And at the crop maturity, crop and weed plants were hand harvested within these fixed quadrate areas. Now we come to what these treatments have effect on biomass. So starting with the crop row spacing, just move this forward, yeah. So you can see from this slide, there is a clear effect of faba bean row spacing on weed suppression. The sow thistle plants planted in narrow row spacing, their biomass was reduced by up to like 64%. Compared to wider row spacing, which is 50 centimeter. And there was a significant interaction between crop row spacing and weed density. So as you see that at wider row spacing, biomass of common soil thistle was much higher compared to at narrow row spacing. So on the top you can see that I have just put two representative photos from the treatments. On your right, you can see that there is, I think I'll just move this thing. Yep, at narrow spacing, soil thistle plants doesn't look much healthier and it's producing less biomass. And on your left, which is wider row spacing, the soil thistle plants looks pretty healthy and is producing more biomass and seed. And these photos were taken at the same time of the crop. So within the weed density, we see that at narrow spacing, both high density of weed and low density of weed were both equally expressed at narrow spacing compared to wider row spacing. So at Warwick, these were results from Narrabri, and this at Warwick, we see that there was a soil thistle biomass was significantly affected by an interaction between cultivar and row spacing. At the wide row spacing, Werther was poorly competitive with significantly greater soil thistle biomass than Nasma. And at narrow spacing, each of the cultivar had a similar effect on the biomass of common soil thistle. I'll come to the effect of crop density on weed biomass. Here you can see we have a very strong suppressive effect of density as well on soil thistle biomass in Narrabri trial. On average, the biomass of soil thistle was reduced by 31%, and as you can see, two representative photos taken at the same time of crop stage, at almost at flowering stage. So within one of the treatment with a higher density, you can see that soil thistle plants, they are pretty weak. They are not growing well. Crop look a bit stressed, but you can clearly see that they are very small at higher density, and it's the same at narrow spacing. Both photos I'm showing on your left is the same variety and the same row spacing treatment, but the only difference is density. So at the low density of the crop, we can see that soil thistle plants, they're growing a bit bigger and they're just sticking out from the crop plant's canopy. So at Warwick, we see that the biomass of soil thistle plants were significantly affected by an interaction of crop density and the weed density. So on average, you see that there's about 36% reduction of biomass of soil thistle when, seed density, planting density of rubber bean was increased from 20 to 30 plants per meter square. And similar effects can be seen on, 5 and 10 plants. However, at high density, even the high density of the weed was suppressed more compared to the wider, low density of the crop. Here you can see biomass of 10 plants and 5 plants at high density compared to there's a gradual reduction, and there's more suppressive effect of density regardless of other treatments, variety or row spacing. I'll come to the South Thistle seed production, effect of row spacing. So at Narrabri, we see a very clear effect of suppressive effect of crop row spacing on seed production of South Thistle plants, which was significantly suppressed by up to 33% when the row spacing was reduced from 50 to 25 centimeter. And there are a few represented photos I just took on the different treatments across. You see that on your right, at the narrow spacing, South Thistle plants are not producing any flowers at this stage. However, on the 50 centimeter row spacing, we'll see that heads are coming at wider row spacing. And those photos were taken at the same time, effect of cultivar and density on the seed production at Narrabri is we see a significant interaction between crop cultivar and density. The cultivar Nasma planted at 30 plants per meter square suppressed the South Thistle seed production significantly more compared to Mung planted at either 20 or 30 plants per meter square. And there's a bit noise here in case of Warda, but we see a trend of, not a trend, is basically the effect of density we can see, and Nasma looks a bit more suppressive, definitely much more suppressive compared to Mung when planted at both at low or high density. At Warwick, we see a significant interaction between cultivar and faba bean density. For Nanu and Warda, South Thistle seed production was lower at the high crop density. You can see that Nanu planted with 20 and 30 centimeters, so there is a significant reduction when density was increased from 20 to 30 plants per meter square. Similarly, for Warda, a similar trend was seen. There was a significant effect. And we see trend was similar in case of Nasma, however, the effects was statistically insignificant. So in general, there was a significant effect of crop density with the higher density, more suppressive to the seed production of South Thistle plants. So across the three cultivars, the amount of South Thistle seed production was similar at high density. I'll finally come to the faba bean yield. So at Narrabri, Nazma yielded significantly higher as compared to Man and Warda. Well, this is very interesting actually. And we found that Nazma was a more suppressive cultivar, and it has an interactive effect with other treatments, the crop density. And however, it is also at the same time, it produces about half a ton more compared to Warda and Mon. Faba bean yield was significantly higher in the absence of sawthistle, as you can see from the graph on the bottom, where you see that compared to weed feed treatment, yield was reduced significantly with the 5 and 10 plants density of sawthistles, which was significantly less compared to weed feed treatment. However, there was no difference between the yield, when it was competed with 5 or 10 plants of sawthistle. And at Narrabri, we didn't see any difference in the yield of faba bean planted at either of crop density or row spacing. So at Warwick, faba bean yield was affected by the interaction between faba bean density and sawthistle density. You can see that the crop yield was reduced by the presence of sawthistles at the low density of the crop, which is 20 plants per meter square. However, in contrast, crop yield was not affected by the presence of sawthistles at higher yield, higher density of the crop. Now, the few take-home messages from this trial. So faba bean crop agronomy can be manipulated to significantly suppress the biomass and seed production of common sawthistle. And faba bean cultivars interactively act with the crop density and row spacing to suppress the weed biomass and seed production. And as I said earlier, the Nazma seems to be more suppressive compared to the other variety. And we have seen this in not only in the field, but also in the bird cage experiment, where we tested like 6 cultivars for different traits for faba bean, and we found Nazma. We have not shown the results of this trial, but Nazma was pretty much more suppressive compared to our rest of other cultivars. So weed management through crop competition is an effective and affordable control strategy that farmers should consider. And so this is just in the end of what we are currently doing. We're doing current free trials on sorghum and mung bean competition on summer weeds emerged in crop at different times. And these trials are done at both Narrabri and Auric currently. And additionally, I'm also doing field trial on effect of mung bean planting time and density on barnyard grass. And at the end, I would like to thank GRDC for supporting this research. This is highly appreciated. And thank you very much for listening my talk.
All right, thanks, Asad. Got time for a couple of quick questions. There's some questions there in the chat area for you.
Okay.
Yeah, maybe I'll just start reading it out for you. So Ken has asked about the implications of this research in regards to disease management. So he's sort of saying, how does narrow row spacing, different varieties, increased growth habit, canopy closure, etc. How does that all influence the occurrence of disease in fava beans?
Yeah, we didn't see any sign of disease. I understand that when you place the crops too close, that may, change the microclimate, and that may, influence the pathogen, activity, and generally which is higher. But we didn't see any. I know I did keep an eye on the, narrow spacing, and we didn't see any sign of rust or charcoal rot, which are pretty common diseases of fava bean.
I think it's
but we didn't see any difference in the yield of row spacing. So row spacing was, there was no effect on the yield actually on fava bean planted on narrow spacing or wide row spacing.
okay. So I think it's fair to say that when you narrow the row spacing and you get earlier canopy closure, that there's an increased likelihood of disease. So for growers, it increases the risk, so they need to be more diligent about monitoring when you've got that scenario occurring.
Yeah, of course. That's
so moving on to the next one from Gulshan. He's got a query about the seed production of South thistle. Some places 400 to 500 seed per plant was mentioned, whereas in others 80,000 seed per metre, 80,000 seed per metre squared was mentioned. So his question is about the plant density at the different locations. Were they different? What's the difference in the seed production due to?
We know that first thing. I think I should have shown you that seeds with only 1 year, the same unit, like the seeds per plant. But I think in general there was more seed produced by the South thistles at Warwick site, but this could be due to some environmental factors, the different sites, and different planting times of the trials. However, the crop competition effects were pretty similar. The trends were similar across both sides in general.
Okay. All right. Thank you, Asad. Round of applause. All right. So next up, we've got Adam, who's going to continue on the crop competition story. So, Adam, take it away.
We'll just okay. Just get myself sorted. Okay, can you see that?
Yep, all good, Adam.
All good, excellent. Okay, so I'm going to follow on from Asad by talking about the chickpea trials that we had at Narrabri and at Warwick in 2019, and then I'm going to go on and talk about the we had sorghum over the last summer and also mung bean over the last summer. Okay, Now, Asad's already been through the sort of theory behind this a little bit, but the idea is to just create a competitive environment where the crop uses more of the resources than the weeds. And then we're trying to quantify any changes to weed growth and seed production, which are caused by our treatments. And the treatments, as in the faba beans, we're using different narrowing the row spacings, we're increasing crop populations and choosing competitive crops. And we also might, in many cases, we've had an effect of an interaction between these, sort of a compounding effect sometimes. We're not using herbicides. This is just to look at the effects of competition on the weeds, not to suggest that growers shouldn't use herbicides, but just more so that if we can show that the competition works by reducing, say, 50% of the weed biomass and weed seed production, then that only leaves 50% of the seed to be controlled by other integrated weed management methods. So it's about presenting numbers to people. So I'll start with the chickpea trial where we grew sow thistle again. So this is pretty much exactly the same design as the faba beans that Asad just presented. So here we used two varieties, Boundary and Kyabra. We had 50 and 25 centimetre row spacings, had a high and a low crop population, 15 and 30 plants per square metre. And we had the three different weed treatments where we had weed-free, we had a low dose of sow thistle at 5 weeds per square metre, and then the high weed population of 10 weeds per square metre. And again, as Asad mentioned, in Narrabri, there was some differences where I believe they planted weeds that had been grown in the glasshouse and weed spread weed seed and then irrigated it up and then thinned. But the result was that we had 5 weeds per square metre or 10 weeds per square metre at both of the sites. We had the crop-free plots to look at how well the weeds grew when there was zero competition. And these trials were also replicated in Wagga by New South Wales DPI. So I'm only presenting results on weed biomass all through this. We've got data on seed head counts. We've got seed production, which we've calculated from that. We've got yield data. We've got LAI data. I saw there was a comment on that. But today, just for brevity, because I've got a couple of trials to talk about, just going to stick to biomass. And weed biomass is strongly correlated with the number of heads that a weed produces and the seed that's produced. So for all of these results, just keep in mind that, say, a 50% reduction in weed biomass is going to equal roughly a similar kind of reduction in the seed being produced by those plants. So the format I'm using, I'm going to go through the Queensland results and then over in the blue are the New South Wales results. So to start with, I've got my little laser pointer, so if you follow the dot. So the in the fallow, without any competition, we had over 1 kilo of sow thistle biomass per square metre, that's dry weight. Compare that to in-crop, all of the in-crop treatments, we had a massive reduction in sow thistle biomass. So that's just the effect of crop. Now looking within just the crop here, we're looking at the effect of variety, row spacing, etc. So in Queensland, we found that there was no effect of variety, no effect of row spacing, but we did get a very clear effect of the chickpea population and no interactions. Then over to New South Wales. So the sow thistle there overall was a little bit smaller, but still the fallow, compare that to the weed biomass in crop, and there is a huge reduction just for the fact of having crop. Within those crop quadrats, they had a significant interactions, which so the variety was affecting the sow thistle biomass, but it depended on the population it was planted at and also at the row spacing that it was planted at. There was also another interaction with the variety and the population where it depended on the density of the weeds that were planted in it. So I'll go through those three results now. So the first one from Queensland, this is the easy one. So we've got chickpea population, and then on the x-axis here, south thistle biomass grams in dry weight. And you can see here when we go from population 15 chickpea plants per square metre down to 30 increased to 30 plants per square metre, we had a 30% reduction in south thistle biomass. And I'll keep going through these graphs, but as they're going to be available online, I would suggest if you want to look at them more closely, especially with things like this, yeah, go and have a look and just pause. You can pause the video. So this is the first interaction from Narrabri. We've got south thistle biomass on the x-axis again. Now, the dark bars are wide row spacings, the lighter bars are narrow row spacings. So we just focus on the dark bars to start with. You can see here, wide rows, 50 centimetres, planting chickpea at 15 plants per square metre. We have a significant effect of the variety. Kyabra controlled the south thistle better than the boundary. When we planted those varieties at a high population, they were equally as successful at controlling south thistle, and both of them were better than the low population. So a high population is good. If you can't plant a high population, perhaps then choosing a variety, something like Kyabra. Looking at the lighter bars, we've then got 25 centimetre row spacing. Overall, they're a little bit lower bars. So overall, the row spacing has affected the south thistle biomass. Here is the low population, boundary and Kyabra. You can see we've got a significant reduction in south thistle biomass of the Kyabra compared to the boundary. And again, Kyabra compared to the boundary in the higher population. And overall, if you were to look at all those bars in together, so this combination of planting is the most successful at controlling the south thistle. So narrow rows, high population, Kyabra, comparing that to the worst, which is this one over here, the wider rows, low population and boundary, and we've managed to get a 72% reduction in south thistle biomass just by the way we've planted the crop and which variety was chosen. Well done, Narrabri. And to carry on from that, so this is a very similar looking graph. This is now looking at weed density in combination with population and variety. So the dark bars are where we've had 5 weeds in a square metre. And you can see a similar effect here where Kyabra has outperformed boundary at controlling south thistle. At a high population though, both of them are equal and no better than Kyabra at low density. So if you had not many weeds, you'd almost be better off just planting, might be cheaper to plant a low density Kyabra, might be your best option, or you can plant double your seed and have a slight improvement, but not significantly different. In the lighter bars there, we've got where we've planted 10 weeds per square metre. And again, similar to the previous graph, but essentially the best combination here is either of these two. Both got Ds, not significantly different. So the population is the preferable method of controlling the south thistle versus the variety really here, because you've got no difference between Kyabra and boundary, and at low population, no difference between Kyabra and boundary. So that's the end of the chickpeas, and we're now going to move on to the mung beans. So the mung bean trial was conducted by DAF up in Kingaroy, and there is trials that were conducted in Narrabri, but that data was not available. So this is just a photo of the trial. We've got Feathertop coming up in the mung beans there, and on the right is just a photo of the trial that stretches down to the tree line there. And we had a similar set of treatments at Kingaroy and at Narrabri. Now we used crystal jade and satin varieties. We had 2 row spacings, high and a low crop population. Now we've got 2 weed species involved. So we had barnyard grass and feathertop Rhodes grass. And we used the 3 different weed densities again: weed-free, a low density of 5 and a high density of 10 weeds per square metre, and crop-free to see how well the weeds grew without competition. Photos there. The top one is the little organza bag I put on the barnyard grass just to collect the seed so that we can calculate how much seed is being produced from all the heads in a square metre, and also calculate it per weed plant. And the bottom photo there is just an example of the feathertop growing in fallow, 10 plants per square metre. The yellow little pegs there indicate the square metre. And so they've been thinned to that density. So we'll go through the barnyard grass results first. So in fallow, we had an average 33 grams per square metre barnyard grass. Compared to in crop, you've got about a 90% reduction there, just from having crop. And then we'll look within those in crop plots. And what we found there, we had a variation in control of barnyard grass from the different row spacings, from the different varieties. And also we had an effect of the mung bean population, but it depended a little bit on the density of the weeds. So now I'll just go through those 3 results. So the first is the mung bean row spacing. Nice and simple, a barnyard grass biomass on the x-axis, 50 centimetre row spacings, and when planted at 25 centimetres, we had a 35% reduction in the barnyard grass biomass. So nice effect of narrowing the rows. Looking at the 3 different varieties, we had no difference in the ability of crystal and jade to control barnyard grass overall, but satin did come out as more competitive, and we had a 22% reduction compared to, say, crystal. So just through choice of cultivar. Okay, third one is the crop population, which depended on the weed density. So the darker bars there are the low weed density, lighter bars are the high weed density. So we had a 17% reduction in barnyard grass biomass when the weed load was only 5 weeds per square metre. When we increased the weed load, so you've now got 10 weeds, so overall there's more biomass because there's more weeds, but the effect of increasing the population also got greater. So now we've got a 38% reduction in barnyard grass biomass from increasing the population. So that was the barnyard grass. We'll go to the feathertop now. So the mean feathertop in fallow, we had 733 grams. And then, I can't calculate that, but it's quite a significant decrease just from having the crop. What's that? Less than 10%, 5%. And within the in-crop plots though, we had a significant effect of the row spacing we planted the mung beans at, but it interacted with the variety we chose. And we also had a 3-way interaction between the population of the crop, the variety we chose, and it was dependent on the density of the feathertop as to how well it controlled the feathertop. So we'll go through those 2 now. So the dark bars here, we've got the wide row spacing. So we'll have a look at those first. So essentially in wide rows, 50 centimetres, satin here was much better at controlling the feathertop than crystal. Jade, however, was just somewhere in the middle there, not significantly different to either of the other 2. So satin came out quite well there, but when we planted the crop at 25 centimetre rows, so overall there's a significant reduction in feathertop biomass from that. But here we've got no difference between these 2, both got C's. But here satin on its own, so of all of the combinations, satin at 25 centimetres did prove to be the most competitive against feathertop. with a 71% reduction in biomass compared to the least competitive, which is say Crystal up here somewhere. So quite a good. So choosing the right cultivar and narrowing the row spacings in mung bean. The second of the interactions, I've just put half the graph up here to start with because there's a bit going on. So this is the low weed density, 5 feathertop per square metre. Now we've got Crystal, Jade, Satin, and within that is the populations of the mung beans. So you can see in Crystal, increasing the population was a good way to control the feathertop biomass. But in Jade, increasing the population had no effect at all. In Satin, we had a very big effect of increasing the population again, and the best combination of everything was Satin again at a high population this time, and a 72% reduction in biomass compared to the least competitive planting configuration. So that's the low weed density. The high weed density is this. So overall, much greater biomass of feathertop because we've got more weeds, but a similar pattern here. So Crystal, increasing the population. Yes, there was an effect, just as there was over here. This time we've got an effect in Jade. So essentially, Jade at 20 plants per square metre became very uncompetitive, and increasing the population improved its competitiveness. And now we've got Satin here, which it didn't matter which population we planted it at. So these three here, Satin at low or high population, or Jade at high population, as well as Crystal at high population, no significant difference. All got C's in them up here. And so essentially planting high population, or high population, or Satin at a low population is a good way to control a heavier weed load. So that is the end of the mung beans. The final experiment was the sorghum, which was conducted up in Kingaroy as well. Some barnyard feathertop taken at the site. This was also replicated in Narrabri. And so we had 3 varieties. We had Taurus, Ripper, and what is now G33. We had metre row spacings and 50 centimetre row spacings. We had crop populations of 5 and 10 plants per square metre, 50,000, 100,000 per hectare. Barnyard and feathertop again at 3 different crop weed populations. And we still have our crop-free plots to let the weeds grow as they best they can, with no competition. So I'll start with barnyard grass and then we'll go and move on to the feathertop. So for the barnyard grass, so in the fallow, 97 grams per square metre. In crop, a less reduction. So that's about an 80% reduction in weed biomass compared to some of the other crops we saw were 90–95% reduction just through having a crop. So it kind of indicates already that sorghum is a less competitive crop. Within the in-crop treatments, we had a significant effect of population. We also had a row spacing effect, which was dependent on the density of the weeds. And in sorghum, we had no effect of the variety chosen, and that reflects the results from the previous summer, where we had also no effect of cultivar in sorghum. So I just don't think the growth habit differs as much as some of the other crops, which certainly shows from LAI data. So go through those two. So sorghum control of barnyard grass. So the sorghum population, when we've got 5 crop plants per square metre, if we increase that to 10 crop plants per square metre, we get a 45% reduction in barnyard grass biomass. And the other interaction we found, so we've got on the dark bars, we've got the low weed density. The lighter bars is the high weed density. So here in the low weed density, narrowing the rows to 50 centimetres gave us a 35% reduction in barnyard grass biomass. High population, similar effect, narrowing the rows was effective. This time it gave us a 45% reduction in barnyard grass biomass. So very good. And the last weed up at the sorghum trial was the feathertop. This will give you an idea. So 900, nearly a kilo of feathertop dry weight per square metre in the fallow, compared to about a 90% reduction in a feathertop in the in-crop. So significant effects, very easy this one. We had a straight effect of the variety that was chosen. We had a straight effect of row spacing, and we had the effect of sorghum population. So the effect of variety, which we didn't get with barnyard grass. So we've got Taurus, Ripper, G33, and there's no difference between the G33 and the Ripper, but G33 gave us a significant reduction by 17% compared to Taurus in feathertop biomass, and Ripper was somewhere in between there. Then the sorghum row spacing, this is a bigger effect. So we had 17% reduction based on variety, but we've got 40% reduction based on row spacing. So metre row spacing reduced to 50 centimetre spacing. We had a 40% reduction in feathertop biomass. And similarly, if we increase the population, so from 5 sorghum plants per square metre up to 10 plants per square metre, we get 39% reduction in feathertop biomass. So population and row spacing is more effective than possibly cultivar choice in sorghum. So conclusions from these 3 trials. So increasing the crop population in chickpea was effective at controlling south thistle biomass. Narrowing rows and variety of choice can have an additional benefit as seen in the Narrabri trial. In the mung beans, for barnyard grass, a vigorous variety, narrow row spacing, or a high population were all good choices to control barnyard grass. For feathertop, a vigorous variety was effective, and there was an interaction there, especially at higher crop populations or narrow rows. So you can do one of those things, but if you did them in combination, possibly more effective. And from the sorghum, so for both weed species, a high population or narrow rows is equally effective in weed control. Sorghum cultivar choice was less important, especially controlling the barnyard grass, and it just gave a marginal sort of gain, but not as effective as rows, spacings, or increasing the crop population. So that's the end of the results, and I'll just do a brief 2 slides on the current trials. So on the left here is our favour bean trial that we've just wrapping up. It's planned to 21st of April. These grew really well. This was about 1.5 metres high, the crop, and we had south thistle coming out. And what we've done this time, we've changed the treatments a little bit. So we've taken the high treatment, the high competition, so which is basically no narrow row spacings and high population. And we're comparing that to the low competitive planting, which is low population and wide rows. And then we're introducing sow thistle at 4 different times. So every 3 weeks we go in and introduce more weeds and then see how they germinate and grow in the crop. So this has nearly wrapped up, just waiting to harvest the final part of the favour beans. And in the chickpeas, it's the same treatments, high versus low competition and multiple times of sow thistle emergence. And that's still just sort of maturing, and we're yet to harvest that one. But there's some sow thistle from the time where we put in the sow thistle at the crop, with the crop, and they're well and truly out of the canopy and being very dominant. So we'll see what happens with those. And then the current summer trials. So we've planted our sorghum trial, which again, high and low competition versus 4 times of barnyard grass and feathertop emergence. So this was planted mid-October, and it's just had about 45 mils of rain on it. And so I'm waiting for it to dry out so that I can go in and we'll start setting up the quadrats and thinning weeds and crop. And Takehome is still the mung bean trial, which would be the same system, same treatments. Okay, thank you. Thank you all. That's it.
Thank you, Adam. Yeah, I think we've got a question there for you.
Do I read that? There you are. Hello.
Yeah, can you see it, or do you want me to read that to you?
I can't see.
Okay, so it says, is satin a spreading type mung bean variety or a rect type? How about the duration of the 3 varieties?
The duration. Is that the last bit?
Yeah, so
yeah.
I guess the growth.
So I mean, there's a lot of data there, crop data available, but from my observations and from taking light readings in the crop, the satin is certainly grows faster, grows bushier, and yeah, it's very dominant cultivar. I think it just gets bushier faster and blocks out the weeds, and I think that's its strength. Is it's either using the resources faster, the water or the nutrients, or it's just physically blocking out the light faster to the weeds, and possibly particularly more effective in barnyard grass. It's more of a prostrate weed. Feathertop coming up is possibly less effective, but it still controls both of them really well. Yeah, satin's good, or something like satin, but something that grows well fast. Yeah.
Okay, good. All right. So yeah, we've got time for another question. If anyone's got one. All quiet, Adam.
All quiet too.
So they're obviously impressed and speechless.
Confused by the figures. Yes.
All right then. Well, we'll probably wrap it up there then. Just a reminder to everybody that thank you for attending today, and thank you very much, Adam, for your presentation, and also to Asad.
No worries. Thank you. Enjoyable.
That's good. Good to hear, mate. So next week is our last in the series. So we've got Michael Thompson who's going to talk about changing seasonality of annual ryegrass, and that's followed by a guy who's going to talk us through laser weeding of annual ryegrass. All right. Thank you all again, and look forward to catching up again next week.
Thank you. See ya.
Thank you.